Now, children, let me begin. And my first question is, suppose, children, if I have this wire, I have this copper wire in my hand. And copper wire, this is a conductor. It's a conducting wire. It's a conductor. But you know that in our previous discussion, we have realized and we have concluded that electrons current flow in a wire due to the presence of free electrons. And electrons, they are free to move in any conductor. Now, children, I have holding this wire in my hand, but I'm not getting any electric shock. Why? Is there any current flowing in this wire? Is there any current flowing in this wire, children? Say yes or no. Calista said it's no. Yeah, you can type your answer in chat box also, children. No. Even if I connect a small LED lamp with the end of this conductor, still that the bulb won't glow. But what happens, children? It's a very surprising. What happens if I have the same conductor, same wire, and if I connect the end of the wire with a battery, or even if I connect this wire anywhere in my house, any outlet in plug, I will feel an electric shock if I touch it. So basically what I am trying to tell you, children, if we have a conductor and if we connect the end of a conductor with a battery, with a cell, with a power supply. Now we are dealing with, children, in our initial lessons about the DC current, with the DC supply, not with the alternating voltage. So that's why this is the topic, children, that we are going to discuss why this happens. Now, wait a minute, children. I want to move to the cognitive. Now, one more question, actually, children. If I draw a diagram, this diagram here, and suppose this is a container, one container, a vessel filled with water. It's filled with water, children. And I have the same container placed parallel to the first one, and the water is also in the second container and at the same level. The water level is same, and both the container are connected via a pipe. Okay, this is open here. It's open. It's open. Now, is there any way, 10th class children, please? If the pipe is connected in such way, is there any possibility that the water will flow from one container to another container? 10th class children. Krish, from this diagram, is it possible that the water flow or water can flow from one container to another container? They are placed at the same level and they are connected with the pipe.
No, sir.
Yeah, the water won't flow from one container to another container. But now the next question is there any way, and what changes should I make that so that the water can start flowing from one container to another? This is your aptitude question. Is there any way that the water can flow from one container to another? The conditions are that I'm not going to decrease, I'm not going to decreasing the volume of water. Anyone from 10th class? Karen? Travis? Madeline? Anyone? Is there any other way that the water start flowing?
Add water in one of the containers.
Okay, you are saying that by adding some water. Okay, but now the condition is that we are not going to change. We are not decreasing the volume. We are not increasing the volume. Okay, children, let me tell you, there is one possibility. There is one possibility that if I make one of the container placed on an inclined surface, like this, on an inclined, means if I change the position, means height, if there is a difference in height between the two vessels, then there is a possibility that the water can start flowing from one container to another container. And now children, this happens with the electricity also, as I have taken the example of what? Example of a conducting wire. Without any power supply, it's not possible that the electron can flow from one end to the another end of this conductor. Even the electrons, they move randomly in a wire. In this wire, still the electrons are moving randomly, they are moving randomly. There are free electrons, and free electrons always move in a random direction. And these randomly moving electrons, they never able to make current to flow in any circuit. To make this electron, I think I need to draw one more diagram, children. Let me take one more diagram. Suppose we have this conductor, and electrons are there. Electrons are there. Let me draw few electrons. These are the electrons are there. And what happens in normal conditions? Suppose this electron is moving in this direction, this is moving in this direction, this is moving in this direction. So they move randomly. And if they move randomly, they never constitute electric current in any circuit. But whenever we connect a battery or a power supply, then what happens, children? All these electrons, which were initially moving randomly, due to the potential difference created by this battery, potential difference that we are going to discuss just in a few moments, children. Now what happens here? All the electrons, suppose that the electron number one, this one, it will start moving in this direction. Electron number two, this also, it start moving in this direction, opposite to the, means towards the positive plate. And this electron, it also start moving toward this direction. Means all the electrons, they starts moving in one single directions. And that I can draw here. This is the direction of the electron in any electric circuit when a battery is connected. And this battery makes the electron to cross or to move from one end of the conductor to the other end of the conductor through a path from negative terminal of a battery to the positive terminal of a battery. This happens, children, in an electric circuit. Now, children, here electromotive force. To explain this electromotive force, just first let me read the definition of this EMF. What is this EMF? EMF is an electromotive force and the phenomena that enables charge to flow. Means this is a battery. This is the battery which make and that enables the electron, when charge to flow, electrons to flow in any electric circuit. And children, remember this, that the force word is coming, but basically it is not a force, it is a EMF, which is measured in volt. So to understand how this EMF work, how this EMF make that electron to flow in any circuit, just focus on these two pictures. Please observe these two diagrams carefully. And these two diagrams, the first diagram and the second diagrams, the analogy between each element of water model represent an electrical quantity. Now see here, in the left hand side diagram, I have a water reservoir, water tank. On the other side, I have a battery, a cell. We have a tap. Tap means tap is equivalent to the switch, that is for the on and off. If I open the tap, then the water starts flowing. The third thing, we have connecting wires in the electric circuit. These are the connecting wires, these are the wires. All the components are connected with the wire. And in this left hand side diagram, we have a pipe in which that the waters flow. And the one more thing, the water is flowing, and in case of the electric circuit, electrons flow. Let me make sign of arrow, electrons flow. And now here, the effect of water to flow, that this water wheel, it starts working. A mechanical work, that the machine will start rotating, this wheel will start rotating. And in this case, due to the movement of electrons, the bulb will glow. Now, in this case, what is happening actually, children? One form of energy. What is the one form of energy? That the potential energy stored in a tank. Potential energy topic that last year we already discussed in grade 9. Potential energy. Energy stored in a container at a certain height. Potential energy, it is the function of height. So that potential energy, when the tap is open and then the water start flowing and the water will gain kinetic energy, means the potential energy start converting into the kinetic energy. And similarly, children, here in a battery, in a cell, it has some energy. It has chemical energy. And when the circuit is complete, that chemical energy is able or make or enables the electrons to flow in that circuit, and due to the movement of electrons and that the conversion of the chemical energy into the heat energy, that the bulb glow. Now basically, what is the role of the battery or cell? What is the role of battery or cell in any electric circuit? The role of battery or cell is to make the electrons to move in one particular direction. Or basically, in another way, you can say electromotive force is the energy given to any charge around the whole circuit. Energy per unit charge is called EMF. We will make a mathematical equation also when we are start with the potential topic, children. So energy or the work done, energy given to the charge particles so that the charge particle can move. That is the role of this EMF in an electric circuit. Now, one more thing, children, that I'm not going to discuss this table, already discussed that water is equivalent to battery, that tap is related to the switch. Now, in extended knowledge here, the EMF is equivalent to the height of the tank. More the height of the tank, more will be the potential energy stored. When you open the tap, then the water will start flowing with higher energy, that the potential energy again start converting into the kinetic energy, and which finally make the wheel to rotate. That the potential energy converting kinetic energy is making some mechanical work, that the machine start working, wheel start rotating. And same thing, children, you have seen, if I write here that this EMF of this cell is suppose 1 volt, that volt is the unit of EMF, it is a voltage. And if I take 2 volt, 3 volt, 5 volt, you should listen carefully, children, that this information you should require in your grade 11, 12, especially while you will perform your IAs also. 1 volt, 2 volt, 3 volt, 5 volt. What do we mean by this 1, 2, 3, 5, 4, 10, 100 volt battery? More the potential, more the EMF, more energy will be given to the charges to flow in any closed circuit. Now let me go to the topic of potential now, children. Then we will write the mathematical equation of EMF and electric potential. Now here, what is potential difference, children? Now in the previous topic, we had discussed about that the EMF, and EMF, that is a battery, and in a battery we have a positive terminal and we have negative terminal. Positive terminal in an electric circuit is considered as the higher potential, children, and negative terminal is considered as the lower potentials. And we know that the everything in our nature, it moves from high potential to low potentials, from high level to low level. For example, water, flow of water. Water always flow from the mountain to the ground. It is not possible that the water can move from ground level to the mountain unless and until we use some external agency like a machine or like an electric pump. But overall, by itself, water always flow from high level to the low level. Similarly, the last year in heat chapter, in thermal heat, you already studied that the heat flow from high temperature to the low temperature. When you make a conductor, if you have a conductor and if you heat one end, and after a certain interval of time, you have seen that the other end also get heated. It means the heat flow from high temperature to a low temperature. And the same thing has happened in the electricity also, that the electric current flow from the high potential to the low potential. Now, what is this potential difference, children? Let me read here. It is the voltage and the energy needed per charge to flow between 2 points in a circuit. Energy needed to flow a charge between any 2 points. What do you mean by any 2 points in a circuit, children? Any 2 points means, let you see this. Let me show you this diagram. In this diagram, a battery. This is called electric lamp. Bulb. Let me write bulb or lamp. And a voltmeter is connected. Voltmeter is connected in parallel. What is the series combination? What is the parallel combination? We will discuss in our next classes also. Now, children, you know that electric current will flow. Electrons will move along this direction. Please always remember, we not need to show direction of electrons. We always show the direction of current in an electric circuit. When this current flow between in this electric circuit, actually now I am interested to measure the potential difference. What is the potential difference here across the end of the bulb? So the potential difference between 2 points in a circuit is measured in volt using a voltmeter, and voltmeter is always connected in a parallel combination. So what is this potential difference? Means at this end and at this end, if I have to measure the potential difference, means how much voltage is required to make the charge to flow between the ends of any component, whether it is an electric bulb, whether it is a resistance, whether it is a fan, or maybe any other component. And that voltage you can measure with the help of a multimeter or a voltmeter. So now, if someone asks me, what is the difference between EMF and a potential difference? What is EMF and what is potential difference? Now, my dear children, please remember, potential difference is the potential across any points, any 2 points in any electric circuits. Any 2 points. If you connect 2 components, 3 components, so the potential difference can be different across each and every component. And the EMF, if we talk about the EMF, that EMF means, if I show you this battery in my hand. So if I see that the reading on what is the voltage of this cell, so I will find that this is the 1.5 volt. So EMF means that the total voltage of the battery or cell when the current is not flowing in any circuit. But when the current starts flowing in any circuit, and then you measure the potential difference across any component, that the value slightly decreases. If you connect, children, now see, if you connect the same battery with having voltage 1.5 volt across a lamp through a connecting wire, and you measure the potential difference, then you won't get 1.5. That value is slightly decreased. Now, why it decreased? Why it decreased? Because the component, the electric bulb has certain its resistance. Some energy is lost while the current flowing in the wire in the form of a heat. So there are certain factors that make that there is difference in voltage across the 2 components. So EMF means the maximum voltage, and the potential difference means the potential difference across any 2 components in any electric circuit. If there is no question, then you can find the mathematical equation of potential and EMF. This equation is very important, children, and this equation you need to remember, you need to memorize, and this equation will help you in solving numerical problems in your exams. So what is this equation of EMF and potential difference? Equation is same, children. EMF or potential difference, we will write same. Both are measured in volt, and this is E divided by Q. What is this E here? This E is the energy required. Or sometimes you can also find in some book, this is W by Q. Work done per unit charge. Remember, in any way you can remember energy given to any charge, E by Q or W by Q. Energy has a unit, joule. Energy is measured in joule. Work done is also measured into joule. Unit of charge is coulomb. Coulomb. So finally, joule per coulomb, or this joule per coulomb collectively called volt. So if you can write joule per coulomb, that is also the correct unit for measuring the voltage. Or just if you write volt, capital V, that is the unit of measuring the EMF or potential difference across the two ends in an electric circuit, children. So W by Q or E by Q, both are equivalent. Both are the same equation, children. Now, if I write in your textbook, there is some information given. If I say that I have a battery whose value is 1 volt, and I have another battery whose value is 3 volts. So what do you mean by this statement? Then it means 1 joule of energy is required to make a charge, to make a unit charge to flow in that circuit. If I say that I have a 3 volt battery, then it means that 3 joule of energy is required to make 1 coulomb of charge to flow in that circuit. That is the meaning. If you find that somewhere you find that you have a voltage 10 volt, so it means battery will release 10 joule of energy to make the charge to flow in that electric circuit. That is the meaning of, children. Somewhere on the batteries, you find that it is a 9 volt battery, it is a 10 volt battery. More power, that means the more voltage of a battery, that stronger the battery of the cell is. And you can connect more and more component with that battery. Example number 1, children. An electron has a charge. Electron has a charge of 1.6 times 10 to the power minus 19 coulomb. How much energy does the electron gain if the battery is 10 volt? If the battery is 10 volt, how will you do this question? How much does the electron gain if the battery is 10 volt? So let me write here the what information we have given. V equal to 10 volt. Charge, and electron has a charge. Q is given 1.6 times 10 to the power minus 19. It is given. You need to calculate how much energy it does. So you need to use the equation V is equal to E by Q. You need to calculate this V E. So this E is equal to, if you cross multiply, rearrange the term, put the value V, put the value of Q, multiply, and then you will get the answer, children. So this type of question, it is a very simple question, but in exams, the basic standard will be the same, but you have to remember that what equation you have to apply. So you can see that the answer. One more question, children. A charge of 1.5 coulomb is measured to have 18 joule of energy. What voltage was applied to the charge? How much voltage is applied to the charge? Can you do this question, children? And please type your answer in chat box.